Hey everyone, welcome to the Unhandled Exception podcast. I'm Dan Clark and this is episode number 72, and 72 episodes into a podcast called the Unhandled Exception podcast, and we still haven't had an episode talking about exceptions yet. Well, here to change that today is Callum Linington. So welcome to the show, Callum.
Hi, yeah, thanks for having me. We've never talked about exceptions, this is the first time.
It might have come up briefly, but we've not actually had a proper, as in... Yeah,
there we go.
I think I'm sure I remember making a joke once or twice about
it's got to be made.
Yeah, exactly. But I don't think we've had a proper. Well, we definitely not had a proper episode talking dedicated about exceptions. But yeah.
So now we've got to handle it. We've got to handle this.
Oh, there's going to be so many jokes like that throughout this episode.
I'm going to see myself out now. I'll just leave. Well,
you've got two doors behind you, so you've got a choice.
Yeah. Can pick one. Yeah. Oh, yeah. It's been a while since our last conversation. I think we did on event sourcing.
Yeah, that was episode 26, event sourcing and event-driven architecture. So yeah.
Good Lord, you've been at it, putting in those episodes. They've been racking up.
They started off quite fast, but it's like less frequent now because of just too many things. But yeah, it's still fun. Yeah. It will carry on going no matter what the frequency is. When I first started the podcast, I said, I'm not going to commit to a frequency because I'm just going to hate it. So actually, as and when I've got time, and it's continuously going, but it's sometimes less often than others.
If you commit to a frequency, it's kind of, it's a job then at that point. It's like a full-time job. So, but I think also like, I don't know if you listen to other podcasts and stuff. So sometimes you want that break for like a couple of months or whatever. So I listen to like Theo Von every now and again, maybe like 1 month I'll listen to him like every other day or whatever. And then I'll just have a nice long break. And it's quite nice that it's there to go to when you want to.
Yeah, so I'm very kindly giving people that break without a choice.
Yeah, that's it. Nice.
Well, actually, soon I'm going to be doing a third Don't Train course because I've done a couple of Nick Chaps's new Don't Train platform courses there. Yeah. So I'm going to be intentionally not recording any episodes during that period just because I want to focus on the course. So, sorry, listeners, there is going to be another break coming up, but as Callum just said, it's good for you.
Yeah. Don't come after me if you don't like it. No, this is Dan's fault.
Yeah, it's all Callum. It's all Callum.
Yeah. Well, how's the Dome Train stuff? Because that looks quite interesting. I haven't obviously looked into it or anything like that, but it seems like an interesting new platform.
Yeah, really good. And it's one thing that's quite interesting is the webcams are on, where like things like Pluralsight, where you just hear the author's voice. I think it's harder to record a course because obviously you've got to be careful about too many jump cuts because you can see the video jumping. But I think from a point of view of people doing the course, it's a bit more engaging when you can see the author.
I think one of the very last Pluralsight videos I watched, which was a while back, it was just cut after cut after cut, and it's just I can't keep track of what's being said because the sentence is chopped up into about 30 different pieces.
Oh, really? Well, I found with audio only, so maybe that was just bad editing, but with audio only, like this podcast, I chop so much, just like zers, all that kind of thing, and mostly there might be the odd one you can tell, but there's so many cuts that people just would not know because I don't know. It's quite satisfying actually being able to really clean up audio, get rid of all my own and ers and things.
Yeah.
But for those, because obviously 26 episodes are quite a while ago, and especially with my frequency, that was probably a few years ago. But
yes.
So for those that didn't listen to the episode or have a memory like mine, could you just introduce yourself to the listeners and tell us a bit about what you do?
Yeah, sure. My name's Callum. I always say you have to do this in meetings where like you're on Teams and it's like especially in big enterprises, like, now introduce yourself, and you're like, okay, my name's Callum. You feel like, should I talk about the alcoholism or not? I mean, we're developers, right? But yeah, no.
I have a problem with exceptions.
Yeah. That's it. I'm from exception. I'm Callum. I'm principal engineer, currently working at a new startup called InsureX. Awesome bunch of people at InsureX, some really smart people doing some really exciting stuff in the insurance space, like really exciting stuff. So I'm really happy to have joined. Before that, just a lot of principal engineering, a bit of contracting. I've been coding, since I was a kid. It's kind of my love. Programming languages as well is kind of like sort of grown as a big love of mine. Love looking at different programming languages and how they work and all that kind of stuff. So that's quite interesting to me. Mainly been in the .NET space, lots of C#, lots and lots of C#. Then moved sort of to F# stuff. I think a lot of people probably know me for F# stuff. I probably annoy a lot of people with the amount of time to talk about it, but it's good language. Been doing some stuff in Go, Rust, C++, just a whole bunch of things. And then more recently, that's where this event sourcing stuff comes in. Over the last 5 years was really getting into the DDD stuff. And then obviously event sourcing is part of that, value objects and stuff is part of that, which when we did the event sourcing thing, just after that is when I started going on the crusades about value objects. So the value of value objects, I did quite a number of those presentations and stuff. So did it like to DDD Southwest and a few .NET meetups around the South. Yeah, so that's where I've been crusading on that. And now I've not moved on, but sort of now adding this exception stuff to the list, because it sort of folds back into the value object to main object stuff. It sort of folds back into that kind of stuff. And yeah, just want to talk about that in general, I guess. And then at some later point, sort of talk about language in general, because obviously exceptions are a language feature. So yeah, there we go. That's me. That's what I've been doing.
Sounds good. Yeah, so you mentioned just then about .NET Southwest. Did I see right that next week you're doing a talk on exceptions there?
Next week, what's happening? Yeah, next week I've got the .NET Reading, where I'll be doing basically this conversation as in presentation format.
Or maybe it was Reading one, but I saw exceptional security, and it was you and someone else. Someone was talking about security. Yeah, so Danielle DS is doing one on security, shifting left group Burp Suite. Oh, actually, yes. Without going on a tangent on that, I only recently heard about Burp Suite because one of my clients had like some security people in doing a talk, and that looks really cool actually.
Yeah, I've never heard of it, never seen it. So that'd be an interesting talk to listen to be honest.
I need to see what I'm doing that evening. I might bob down, and then obviously your talk on how to avoid exceptions.
Yes.
But before we do dig into exceptions, I'm just going to do this episode's listener mention. And this one goes out to Neil Doherty on LinkedIn. He posted another excellent podcast that, as a bonus, helped the time go much quicker whilst I was on the treadmill. And he was referring to the last episode where I was joined by Scott Sauer talking about GitHub Actions. And if any of the listeners want to get mentioned on the show, just send a social post at mentioning me on any of the socials. All feedback is greatly appreciated, and it also helps me spread awareness of the podcast. And don't forget that this podcast has its own Discord community. If you head over to the website unhandledexceptionpodcast.com, you'll see a big Discord link there, right next to a link where you can subscribe to my monthly newsletter. Hint, hint, nudge, nudge. And then, and lastly, a quick reminder that this podcast is sponsored by Everstack, which is my own company providing software development and consultation services. For more information, visit everstack.com. And we are looking for more sponsors currently, so if you're interested, do get in touch. Right, shall we talk about exceptions? So I'm going to throw an exception, and I want to see Callum catch it and see what I did wrong. Ready? Throw new, and Callum's doing the catching thing. Throw new unhandled exception podcast. Now I'm curious how Callum's going to handle an unhandled exception. Where do we start?
Where to start? I think a good place to start is like, what are exceptions? Why do they exist? And what are they supposed to be used for? Because I think sometimes when you look at people's code, that kind of gets lost. I think everyone hears about the, exceptions for exceptional circumstances, but rarely do I see that ever followed. So in the .NET framework, what are exceptions? They are actually an implementation over the top of the Win32 exception stack. And I think they were supposed to marry up quite closely to the C++ exception stuff. And really they're there to catch any sort of hardware issues that go on, and if any unexpected issues go on with the hardware, and that's when you should throw them and catch them. But yeah, this is where I think with exceptions, this is where it kind of stops, right? Because I think people sort of go a bit over the top with exceptions after that. You see things like guard methods. Everyone puts guard methods all over their methods. Some people do. They put guards all over their methods and throw exceptions if things aren't in the right state. So you just got all these exceptions being thrown everywhere. And then it's sort of like, well, at that point, what do you do? How do you sort out your exceptions? What exception do you throw? That gets a little bit more tricky, isn't it? Do you start creating your own exceptions and start throwing those? Do you have like your own? Well, you can't have application exception. There's actually, if you actually look into the documentation and exceptions. Exception guidelines as they are laid out by the .NET standard. You're not supposed to ever throw an exception. You're not supposed to ever throw a system exception. You're not ever supposed to catch an exception. You're not ever supposed to catch a system exception unless you intend to rethrow. And you should avoid catching those top-level exception handlers. And you should never throw or derive from an application exception, but you should throw an invalid operation exception. And then it just goes on for a whole bunch of these other exception types, how you're supposed to work with that.
Just taking that first one where you said you're not supposed to throw an exception, just to clarify for the listeners, do you mean the actual top-level exception
system
class?
dot exception.
We're not saying don't throw an exception, we're saying don't throw the exception class.
Yeah, don't throw it. Yes. Cool. Thanks for the clarification. Yeah, do not throw a system dot exception or a system dot system exception. Naming things. But yeah, so there's two problems in that. First of all, that's a whole bunch of stuff that you got to try and remember. And it's like, how on earth do you remember that? That's not, I mean, to be honest, I never knew half of that stuff until I started looking a bit deeper into it. And I bet no one else really knows all of those intricacies around how you're supposed to and how you're not supposed to. And then on top of that, you're not supposed to catch exception, yet system exception is the base exception for every other exception. So anytime you implement an exception, you'll probably inherit from system exception and should or should not make it serializable, something like that. So to start catching things broadly, and as it says, unless it's a top level exception handler as well, where you're supposed to catch and do something with these exceptions. And if you reuse the same exception over and over again, like how does that work for bucketing out like what the issue is? So an example of that is, say you write in an API, most APIs will always return back to a value, right? Same with a console program. It returns back to a value, right? It should be turned to an int, and that int will dictate whether it's successful or not. So it should always turn back to a value. And in HTTP terms, that could be a whole bunch of different status codes, which mean a whole bunch of different things. And so when you're writing and throwing exceptions, how do you then bucket each of those exceptions back to a particular point? And if you accidentally use an exception for both maybe a 400 to say it's a bad request, or use an exception for a 200 for like a 500, for example, an internal server error, like what happens if you accidentally cross those? Then you get the wrong status code out. So you get this idea of bucketing. But I'm going to put that to one side for a second, and then just go back to sort of the other side of this, is like the actual implementation of exceptions and exception handling. And this is the part which I don't like particularly. I'm not particularly a fan of how they've been implemented. First of all, with these exceptions, where are they documented?
In code, I guess.
Hopefully. Hopefully.
I guess the thing is, if you're writing your own custom exceptions and you're naming them well, then that probably is in code. But
an interesting exercise for the reader or the listener, or unless I know whatever. But the interesting exercise for the listener would be to go and take the HTTP client and make a HTTP request and make sure you handle every possible exception that could occur. And you'll see how difficult that is, because you have no idea. And for the underlying framework, just to be able to just throw exceptions out left, right, and center, and you just have to, let's remember, right, what happens with an exception if it's not handled? It goes all the way up to the stack. And in the C and C++ implementation, there's always a top level handler in the linked list of system sections where it will take that and then throw it back out to the user and say, shit's hit the fan. And the same you get with like .NET, right? So at some point there's probably some kind of exception handler in the runtime which then just goes, we've bottled it. What are you going to do about that? And that brings your whole entire application down, which is crazy, right? If you haven't handled an exception that you didn't know was being thrown, could take your entire application down. Like, what does that mean for like banking systems? What does that mean for other financial systems like trading systems? What energy trading systems? What does it mean for these applications which, just having a random exception is thrown is like, cool, you just brought down my entire application. Good stuff. That's good.
I can't remember in the list of rules that you read out before, was one of them you can't catch the raw exception class?
Yeah.
Because that conflicts with as in what you've just said then, where how do you handle those? The only way you could do it is to handle all exceptions by handling that. But if you're not supposed to do that, then it's kind of, totally.
Well, this is it. But like, even if you, the other side of handling is the other side of, so that's catching. So we're talking about catching exceptions at that point. Like handling them is a whole nother, thing, right? Which makes it even more difficult. Like, how on earth are you supposed to handle some of these exceptions that come through?
So what's the difference between catching and handling?
Well, so if you caught like an out of memory exception.
Oh, do you mean what you actually do when you get that? When you catch
how
it,
do you deal with that?
Yeah,
How do you actually handle that? Like, so it's one thing to catch an exception, but it's another thing is like, what do you do when you've caught that exception? Which is probably one of the reasons why the guidance isn't to catch exception, because you might get an exception which you're not supposed to, or you're not, how you can't handle. Only the runtime can do something with it, and if the runtime can't do anything with it, it just explodes, right?
Yeah, one thing that I don't like about the handling, and again, this might lead on to maybe we go back to this later, but the language syntax is even variable scope. If I've got like a try block and I'm assigning a variable in there and I want to use it below that try catch block, then I've got to take the variable out of scope, and it's just...
I'm glad you said this, actually. And just before I continue, I'm going to take my jumper off because I'm getting hot. I get animated, I get hot, I'm just, Right. I'll turn the camera off. I don't want to avoid, any flabs coming through.
Too much information.
Try to be as discreet as possible. Cool. Yes, right. So try catches. Let's look at the implementation side of it as well now, because you bring up a great point, and it, when you actually start looking deeper into the implementation side of it, it gets really annoying. So first of all, you're right. Try catches as a statement. Statements are annoying. They are annoying. I don't care who wants to argue that point. Statements are annoying. This whole like you say, how do you resolve a try? Because a try catch might just be like, well, if it does this, set a string to this. If it doesn't do that, set a string to something else, right? It's like something really bad could happen, but really the result, handling it, is in both cases is going to return a string. Like the string might be like, cool, this worked, or no, it didn't work, in the case of maybe like console applications, for example. So yeah, it's quite reasonable that you would, that the result of a try catch should go back to a string. And because try catch is a statement and not an expression, your code becomes more verbose. Another problem is because it is a statement, it indents your code further. Right. And I know C# can get very indented, and Microsoft went, you know what we should do? Let's make it namespace file scoped. So let's remove the namespace indentation so we can shift everything to the left a bit. And it's like, that doesn't matter. You do an if and then a try and then a for loop, and you're just now 6,000 lines in, 6,000 indentations in, and your code becomes a lot more difficult to do that. And again, go and have a go at the HTTP client try catch, because you'll see with all the amount of different catch statements as well, and especially in the terms of a HTTP client, you might want to come back to just an error, some kind of error object where you're saying like either it did work or it didn't. It becomes a lot more difficult because of it being a statement. And the other side as well, which I think we touched on a little bit, but I want to sort of explode up a bit, is the top level catch. So exceptions, when you throw them, I think one of the reasons why, don't quote me on this, but I think one of the reasons why it's expensive is because of the unwinding of the stack trace. So it has to unwind to find a catch statement and then handle it. So I'm not going to bother going too much depth on the performance side of it, because Nick Chapsas did a video on this, and you should look back to, he says something about, you're handling exceptions wrong or something like that. Some kind of clickbaity title.
I'll include that in the show notes just for listeners' reference.
Yeah, you can go and find it. But yeah, no, but he goes through the performance differences, and I think it's somewhere around the mechanism of catching, because essentially you don't necessarily have to throw then catch in the same sort of scope, or even a scope above. You could, and happens, the .NET framework could throw deep into the depths of their framework, and then you could catch it right on the other side of your application, right? So the general idea with, being able to, throw anywhere in a stack and catch it anywhere, even at the top level, catch it wherever. The idea is you probably want to catch it closer to where the exception gets thrown. But then as soon as you catch it, you got to do something. And some people tend to go down this path of using it as a control flow, which is one of these big things is when you're using exceptions, when they're saying, you shouldn't control flow with exceptions, right? And that's a bad thing. But then it's like, well, what some exceptions sort of push you towards that area, right? Some of them aren't so big. Some of them are just like bad format exception, URI's wrong, or, or maybe it's an bad input exception or whatever. But it's, it's not the same as like you've got like a system level, out of object exception that's kind of going crazy. So, but the idea of the fact that like there can be any amount of gap between this and you can catch at any single point, which means you can just negate, this is the problem, you can negate tons of code because you've thrown here and caught up here. You don't have to unravel anything that's just happened in between, which obviously has issues with things like, if you're doing a transaction, for example, and you threw in the middle of a transaction, you can just negate everything that's just happened and pop out of the code somewhere over here. So it's a glorified go-to. It's go-to with extra steps.
Yeah, that makes sense. So are you saying that you should try and catch it as close to the throw as possible and then deal with that exception how the requirement should deal with it in an application way, like maybe return?
This is a great question. So this is where I think like we've talked on the exception side of things, like how do we actually manage this, right? What are our options for managing this? And, we can move into talking more about sort of like, how to avoid exceptions, right? Like what is the answer to avoiding exceptions? So just to be clear, at the beginning of this, just to be clear, exceptions are really useful. There's no doubt about it. And they're really good to say like, well, this should never have happened. Why am I here? And you'll see my code is littered with things where it's like, we should just not be here, like as an exception message. Like this shouldn't be a thing.
I think we've all written that comment somewhere saying, should never get here. I think every developer's written that comment at some point in their life.
Yeah, and the thing is, it informs someone the wrong way. So, like, if you go and try and debug it, you might be forced to think, "Oh, I'm not going to put a breakpoint here because it should never get here." When actually, because we're saying it should never get here, you should probably put a breakpoint here because it probably got here.
But also, if you're looking through and you have got there, and it's like, and you're looking at a comment saying we should never get here, it's like, but I am here.
yeah. What do I do?
It does not compute.
Yeah. Oh, it gets crazy. This kind of this statements. I'll say that statements are in part the problem here as well. Like having statements which allow you to just fire and forget. You get into random places and and fake it. The whole nullable thing. Good lord, the whole nullable thing can. Anyway, we'll move on to that stuff. So exceptions are a good thing, and you really should use them to kill your application dead. And why I think that's a good thing is because it's when you go to testing, and no matter what your testing mantra is, whether you like to do TDD or whether you like to do a loose level of TDD or whatever your truth is when it comes to test it. I personally like to do, especially when I want to move quick and I want to get things built quickly, I tend to do very much integration black box testing from the outside, right? So I use the ASP.NET Core integration test thing, and I have a test project which spins up your process, and you can fire HTTP client calls at it, and you're really testing from the outside in. So you're really on the general behavior, and that way you're not tightly coupled to all the stuff that's going on. So if you need to quickly switch something out, the test should stay the same, because it's like, given a new user and I've posted it to you, you should have saved it. That should happen no matter what the internals are doing. And really, I don't care what the internals are doing, as long as the perf looks half decent. And like I said, it does what it says in the tin, then whatever's in the tin, I don't really care about. So that's how I like to do.
So out of interest with that one, where you've done that, your endpoint is creating an order in a database. From an assertion point of view, do you call the same API and do a GET request, or does your test directly check the database?
Yeah, that's definitely should be a per scenario basis of whether you pick which one you want to do. I do a little bit of both. So I've been using Surreal DB, and there's a blog post to follow actually setting up Surreal in Azure. But I use Surreal DB, and I use it with test containers. So I use test containers with my ASP.NET Core integration tests, so that all the supporting services I can just fire off in Docker. And sometimes you just want to straight up check the database, or you can use the other. I tend to just use the GET request, to be honest, which might give you false hope, or it might show some more problems. But to be honest with you, case by case basis, whatever you feel is appropriate. But both I think are a solid choice.
Yeah, sometimes I find that if my tests are depending on, well, obviously it has to depend on the project you're working on, then it's probably also got access to the entity framework entities. So it can just use entity framework to just do the assert to make sure that the thing was in the database if you want to do it like really productively and quickly.
Yeah, this is it. And I think like this is going to be an underlying theme to this, which I bet you weren't expecting. But the underlying theme is like, it depends how much you can be asked to do it. Because believe it or not, this is where I think that's going to be one of the underlying themes. Whether you can be asked.
I think that's it. It's kind of, we've got to be honest here. It's kind of like developers cut corners because they can't be asked. And like,
it's true.
Yeah, it's kind of, we don't want to like, with these kind of conversations that are on podcasts and things, they talk about the complete ideal scenario. You should be doing this. But we need to talk about reality and what developers really do.
Yeah. And I think it's an interesting point as well, because I think you get two sides of the story. Like, and I've definitely been on both ends of this, where it's all about that developer curve, right? Where, as a junior, you do the most basic thing. And as you get to senior, you chuck in all the patterns. And then, by the time you get to, whatever else is after that, you're dig back to simplicity again. But I think, I've also been on both sides where like you do very little, then you try and do absolutely everything. And then you realize that actually you need to be somewhere in the middle. What I tend to find at the moment is that I feel that people have swung back to doing nothing. And actually we need to push people up to doing a little bit more than that, but through mechanisms of making it easier. So hopefully the rest of this conversation should sort of help like bring people up, rather than trying to say you should do absolutely everything, and do everything absolutely perfectly all the time, because sometimes it's just not a reality. But doing nothing all the time as well is not a good place to be in either, because it creates a lot of difficulties.
I think it's just getting people to think about it and be aware of the different options, and rather than saying you have to be doing this, you should be doing it this way. It's just the more ways of doing things and the more people can learn from other people learning the hard way so they don't have to. And I think that's the great thing about conversations like this, the more like podcasts you listen to or things where you're hearing other people's experiences, and then you can kind of, in your own head, aggregate those and try and do the right thing from what you've learned from all these different sources.
Yeah, and that's another interesting point as well, because I think, obviously information overload is a real thing. And I think this is where a balance is sort of trying to be met, isn't it? With, you could go and look into the nth degree of everything and then, listen to all the sides of the argument. And now you've got like this boatload of information. Now you've got to try and distill what does the good path look like. And I think, that becomes really difficult, especially if you're on the more junior end, because you haven't had the experience to see how all this stuff sort of pans out in sort of big systems or small systems or high performance systems or low performance systems. You haven't had all of those different axes to think about, what a good solution looks like. And really like always trying to be less dictatorial about things and trying to sort of like nudge people towards looking at stuff and just trying things out. In fact, I think a lot of the time, hence why I said about the try catch around the HTTP client, it's about trying it out, have a look for yourself. See, I think it's really good to tell someone, the history where this stuff came from and why it is the way it is. And then, some of your options on the other end for actually dealing with that. And then sometimes what you think the best option is and what they should do. But, yeah. So I think wrapping back to this, to the testing and, and why, exceptions are really useful in the sense that you can throw it, you want it to fail fast because then you want your test to fail fast. So I think that's a really good use of exceptions to kill you dead before you go to production. You have to remember to try and squeeze out all of those bits before you go, right? So you're throwing these exceptions and you want to be able to write the happy path and it all works fine, the exception's not being thrown. But if you do get to a part, you just want to kill it, you want to stop your test as quickly as possible, right? You just want to say we're failing at this point, this shouldn't be happening. So that's where I think exceptions are good. So what are the options for dealing with
It was making me laugh before because we've said options quite a few times, and I have a feeling we're going to go in that direction about talking about options, as in like the functional options maybe.
Yeah, so I mean, I think it's well known, and a lot of people have told me, because I've obviously written a lot of blog posts on this, and again, that should be linked in the show notes. But I've written a blog post on this, and I think some people have mentioned, like, I had some really good feedback on a lot of these, and a lot of people write a lot of different comments, and it's been great to read them back. And actually, I think, someone did pop up and say, this is the age-old debate between, exceptions or errors as objects, right? So, so your solution is, your alternative, as far as I can see, or a decent alternative, is to use objects as errors. Now, how you do that is, yeah, like you say, there's a little bit of more finesse and a little bit more nuance on how you want to do that. And I really think it's really, you got two options really. You can either use like discriminated unions, like the one-of library, or maybe if you're watching this from the future and you're like, oh yeah, C# has these now. Cool, good, probably should use those.
That sounds like it might be quite far into the future, or maybe not. There's been talk about it more recently, but I still think it's probably a long way off.
Yeah, well, this is it. Who knows? There's a lot to sort out with it, and again, we can talk into the language side of things, but yeah, there's a lot to sort out with it. But then, and then you get that, or you can use the either object, either fail or success, or either left right, depending on how you want to look at it. And I think these are your two options really, and I would always prefer to use either, and that's where my posts go is, how can you use the either. I'm going to say, well, the either object, I'm going to say monad. I might as well get it out of the way with, because I know people are probably sitting there going, it's a monad. Yeah, cool. It is the same as a list and a task, right? So it doesn't really matter. It is, but it's also just an object, and it's an object which has two paths you can go down. You can either go down the success path or you can go down the failure path. And I think, these are your options. Now, having said that, does that solve all your problems? No, it doesn't. It doesn't solve all your problems. Does it make exceptions go away? No, it doesn't make exceptions go away. Exceptions are still there, front and center, super duper annoying. And does it make them easier to use? Does it make your code better in terms of when you do get to try catches? Not really, because for the reasons that you said before with statements, either object allows you to return either a fail or a success to that same object. So what you'll get is two paths being able to return back to the same value. So therefore, expressions would work really, really well with this. Notice, I don't know if you notice, you can actually, like obviously since one of the earlier versions of C#, you can actually throw an exception and expression now. So they thought about throwing and like, oh, you know what? It'd be great rather than having to do if this throw, we can just do coalesce to a throw or something, right? So like if this is null, then throw null implemented or whatever.
It does sound like, whilst useful, sounds very wrong as well, because it's not an expression anymore, is it? Or it's not pure.
Yeah, well, no, 100%. Yeah, exactly.
You suddenly introduced a side effect.
Yes, exactly. And they only thought about it on the throw case. They didn't think, well, what happens if you need to try catch back to a single, whatever. They've done switch case, which, the switch expression has been a godsend.
Definitely.
I've absolutely loved using it. And my code is now littered with it because it's really useful. But like, why didn't you pick? I don't know why exceptions has been kicked to the curb. They've gone, right, what are all the things? And really exceptions has been left by the wayside the entire time. It's just no one's ever cared or bothered with them. It's just, it's just exceptions are exceptions, and that's the system. And it's like, that can't be the best implementation. Come on now. You can't have created it back at the beginning of C# and still think it's a great implementation, because we've got things like primary constructors, throwing expressions and switch expressions. So much of the language is changing. Like, clearly you're saying that actually maybe some of the stuff you did at the beginning could be improved upon. Exceptions apparently not.
I think the thing is, like, languages are iterative and they can only do so much. They're doing a new version each year now, so it's kind of, it's definitely each version is improving as a language. So I think it's just things are going to take time. But just going back to, you were talking about like the either class, and yes. I joked about the options class as well. So that's another kind of maybe listeners that don't know about this kind of either options class maybe missed that one. But can we talk a bit more about that, because I think that is kind of quite a key thing. And I know we've had in some past episodes we've had Simon Payne, who's quite into functional programming in C#, and so he's spoken a lot about that. And one thing I quite like about it is the fact that when you call those and those call methods that return those, you can chain those together, and so you can have like a whole bunch of function calls telling a story. Halfway through, one of them can be returning an error, but the calling code doesn't care about it. It just will stop calling those chained methods. And that just feels really clean.
Yes, let's get into that. So you get the option of T and maybe or either. So either, it depends what the language calls it. It could be either or it could be maybe. You get both of these. And the nice thing about these objects is they force you to deal with both paths, right? So option of T basically returns you either the value or a none, and you have to handle them. So obviously the big issue with try catch and statements and nulls is you don't ever have to handle them, which is absurd. To me, it's just absurd that you never have to handle them. And they brought this whole nullable stuff in to try and combat that. If anything, now you've got exclamation mark, something, 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 question mark, something, something, exclamation mark at the end. And it's just made for the syntax to look really awkward in some places and harder for newbies to come along and be like, I want to program C#.
I think especially when you've got the exclamation mark you mentioned, which kind of ignores something that could be null, and you get, especially you might get people like that come in, oh, there's a squiggly, they're saying a warning. Oh, well, I'll just throw this bang operator in and ignore it, and then you still get your exception. You still get your null reference exception.
Yeah, and the one thing about, the whole point of bringing the nullability in, the whole point about options and the whole point about that is that if you create a class with a property that may or may not have to be set, just making it nullable is it's a get out of jail free card. This is the thing, same with exceptions. It's kind of like these get out of jail free cards where you don't have to think about it or deal with it. And really, actually, if you dealt with it at that point, and done right, then that's a much better place to be in. So for example, with the property, you can use the option, right? So you can say it's optional of. Why that's different to null is because it's an object that you have to handle. You have to call either the maps or the reducers on it, or the selects and select manys if you're a link person, or you have to finally get the value out, which, if you think about a list, to get a value out, you either call first or you call the square, the indexer, and pass it through an integer for your indexer. And with options, you can call match, and match is the way, but you have to, in the match, you have to deal with the none case, and it makes you deal with it. And I think that's the really powerful part, the really, really powerful part of it. An option might not be the way around. This is why we talk about the discriminated union, because actually, there was a while back, a long time ago, the null object pattern. And the null object pattern, I suppose, was a way to get around this idea. So if something could be null, rather than making it null, you just make the null object version of it. And you can see this in play even today if you go and look at the null logger. So if anyone ever tries to mock out an iLogger of T in the .NET framework, go and look up the null logger, because that stops you having to mock it. And it basically is the null object pattern. Yeah, so you can use that. So this is the thing, this is why the one-of's quite good, because you can actually say, well, actually, it might be a few different states. And with some of the stuff that I'm doing with Insurix at the moment, I'm creating a schema, where we can create our own custom schemas with multiple dimensions and data, and you can write data with multiple dimensions, basically have different versions of both schemas and data, right? And in some cases, you might want some schemas to reference another schema. And in some cases, you don't want that. So you clearly here, you've got a property where it's either going to be not set because we don't want to reference another schema. It's an unresolved schema, aka it's just a pointer to say, actually go and look up the address schema, because that's what we want to use as our schema for this property. Or it could be a resolved schema, so where I've had to go off to the database, grab the data for that schema, brought it back in so you can validate against it. So that was just to say that there were three distinct options, three distinct paths or points in time that this thing could exist in. And so the discriminated union was a better choice in that sense, not just optional. And then when you take this a step further, right? So with option of T, it's option of T. So it's only option of one type. And because the error case is always none. And that's not very descriptive, right? That's not very descriptive at all. What we actually need is a failure case. We need to be able to say, if it is an error, how do we encapsulate that error? Right? How do we encapsulate that error? And this is where we sort of start to see where either can actually handle the try catch in a much better way. And I think I remember going, because now we're talking DDD things, right? Now we're talking sort of domain style things where we can split our errors up into parts of the domain. And I think I saw, is it Milan on LinkedIn, who's always chucking out those guides on things, and he does it all right. Some other people literally just look at the docs And they go, did you know about this? Yes, because I read the docs. And you just made it a pretty colours, and you're like, that doesn't tell me anything. If you want to put that stuff out do it like Milan does. If you want to put that kind of stuff out onto LinkedIn, for the love of God, put a purpose behind it, or like why this is a good thing. Don't just say it can be done like this or this. That doesn't help anyone.
No, his stuff's really good. It's got quite a good newsletter as well, which I'd recommend. I'll throw that in the show notes because he goes into like all this stuff, and most stuff he puts on LinkedIn, he also does a follow-up newsletter thing with, which is quite good.
Yeah. I think the follow-up is definitely worth it in a lot of cases. But I think one of his, he was like, we're talking about DDD, and here's the domain, and you can throw domain exceptions. And I was like, boo, do you really want to be throwing exceptions in your domain? Is your domain in an exceptional state that often? Surely not. Because really, if you're in your domain, you should know all the things that go wrong. So that immediately cancels out the idea that you can throw an exception, because there shouldn't be any exceptional circumstances at that point, right? If you think about let's think about just a banking one, because it's a real simple one, because everyone knows that, right? Because everyone's got a bank account, right? And you think, I'm going to try and withdraw £10, and I've only got £5 in the bank, which is my current state at the moment. Times are hitting hard. But yeah, you're in that state. There's no need to throw an exception. You can just return back to these insufficient funds. There doesn't need to be. It's not an exceptional circumstance that someone's going to try and withdraw more money than they have in their account. That's a very normal. That's to be expected. Even going over the overdraft limit, you've gone over your overdraft limit. Yeah, that's an expected thing to happen. You've set a limit and someone exceeds it. That's a very, if someone exceeds it by about 500 million quid, then you can be like, hang on a minute. But they've got systems there in place to catch that kind of stuff. But that's an exceptional circumstance, not just the fact that you've just gone into it.
But is that an exceptional circumstance as far as throwing exceptions are concerned? Because even that is an application thing.
Again, yeah.
Would a fair thing to say is that an exceptional circumstance is anything that can't be covered by an application requirement or something? So as in like business logic, I mean that kind of thing. Everything else, like a hardware failing or a service-to-service call failing, you basically need to handle it and then return something that means something to the caller.
This is it. This is why when I said at the beginning, I did event sourcing because it's definitely on, it's part of the whole DDD thing. It's one of those tactical patterns. And I really wanted to get people into DDD more, but it's really hard in big enterprises or medium to large scale companies, because you might already have a set of code there and you need to try and find your way to DDD. It's not always possible to say, stop everyone learn DDD, because it's a business thing just as much as a developer thing, and let's all collaborate in a DDD way to get the result. That's not practical. That's not going to happen. That's not practical. But what is practical is you can, maybe start to take some of your code and sort of move it, shift it on a bit towards the DDD thing. One of the strong parts of DDD is domain objects, aggregates, value objects. That's why I chose value objects and went on a crusade about value objects, because I thought, if there's any good place to start where you've already got an existing code base and you sort of get more DD-ified, start turning everything to value objects. Start thinking in your domain in terms of behaviors and how people should act on objects and that. And once you then do that, you then start to have what I really wanted to do is start elicit more conversations between the developer and the business analyst. So you can sit there and be like, I've actually found that, once I've had to handle all of my errors, there's this case where if this happens and this happens and this happens, there's a case there which we're not handling at the moment. Is that a thing that can happen? And they can then go, that should never ever happen, right? And let's talk about that in a sec. But then they could say, yeah, that can happen. Oh, okay, cool, that can happen, right? So that should just be encapsulated as an object and returned back through the failure stack, so that we can then go, oh, actually this case that was throwing exceptions somewhere else in the stack because you got to an unexpected state. Actually, we handled it at this point and we sent it all the way back to the user saying, oh, you've actually managed to get to this point, which means this and this and this was wrong. So please go and correct it and come back. So the idea was that, we need to elicit more conversations between the developer and the business. And that comes full circle. Hence why I'm now talking about exceptions, because it comes full circle back again with exceptions, where you're like, it's the part of your application you can start codifying and getting the business to help you understand what are exceptional circumstances and what are just objects, which is super, super useful.
Yeah, I guess a lot of this kind of thing is asking yourself questions as you're doing it. as in, like, don't just randomly throw an exception, because, as we said before, it's quite easy to. Quite often developers can't be asked, so they take the shorter version, and it's quite easy to just, I'll throw an exception or something. And it's like we were talking before about like different languages and things, and being forced into the right way of doing things. If the language through compile errors, like for example, some kind of switch expression that you have to handle all the different cases or whatever it is, then, or like you're saying about options, if it's you've got to handle the unhappy path as well, and the compiler forces you, then you can't take that I can't be asked quick shortcut, because it needs to compile. So
I'm glad you talked about this, actually, because you've moved on to the other part. So the part we just discussed was more of sort of like the businessy type things around it. It's more of just like the conceptual stuff. But talking about the implementation, right? Because I think, like you just said, and also going back to what you said, like being able to chain these together, right? The implementation's pretty cool. So with either, it's essentially a short circuit. And at any point that your code fails, it short circuits. And you then it will then unwind back through, which is much faster than unwinding a stack and finding a catch. It's better just to go, if failed, return failure, if failed, return failure, if failed, return, all the way back up through until you get to the match. So one of the things to remember is that with these objects, either objects, option objects, list objects, at some point you're going to want to get the contents out of it. The same with tasks. At some point you're going to want to get the result out of it. So with task, you can do a wait. With, like, we've already discussed what you can do with lists. We know options equivalent now is match. Either has the same thing. So even though you've got all of these eithers chained together in the select many sort of style, which in terms of functionalness, or how most languages call it, map and reduce style, all the way through. And as soon as you're unwinding the stack, coming all the way back up the stack, at whatever point where you do that match is where you get to handle this stuff. Now, this brings up two very interesting points to talk about. Going back to your original thing, the compiler getting you to help you. If you use a discriminated union for your errors, as your application grows, you can add in as many errors as you like into the discriminated union. Caveated. I'm just going to caveat that slightly. But you can add as many branches of that discriminated union, many error objects as you like into there, as your application grows, as you find them, and you get an easier time to categorize them as well. So you can say, actually, this is a set known as the validation set. So that should throw 400, or that should return 400s. These are the deep internal validation issues, which are actually sort of system problems, like application problems that, are not 400, but they're a 5, and like we've seriously gone wrong at this point. To all the way to like fatal things where we can say, like, this is a 500 if I've ever seen one before. And what happens is, when you use discriminated unions, which force you to handle every single case, any time in your code where you add a new error, guess what happens?
Lots of compile errors.
Exactly. The match, well, hopefully only about 2 or 3 compiler errors, but that happens over the root match where you said handle the error case. That handle the error case is just a method which takes a discriminated union of errors, matches against those. If any of those are discriminated unions, matches against those, and walks through all of the trees, all of the possible branches, and handles them all in one place. I like to handle it all in one place. Handles it all in one place. And therefore, if you've added a new validation error because you've got a new property that needs to be validated in a certain way, and it can go wrong 3 different ways to Sunday, well, you can take those 3 different errors, whack them into that struct. Oh, and suddenly it's compiler error there. You can't do that with exceptions. That's impossible. The compiler's not there to help you. This is one of the things I want to shout from the rooftops at the beginning of this conversation, was the main problem with exceptions is that the compiler's not there to help you with exception. I mean, Java, it does a little bit.
I wish the listeners could see your emotion going into this in the video. It's kind
of... The arms are flying around, I'm hitting lights off the walls. I've punched a cat in the face. So like, honestly, it's I don't know what the cat did to deserve that, but honestly, when talking about exceptions, exceptions, man. But yeah, so this is the main problem, right? Is that the compiler's not there to help you, and this is why C#'s got a glorious type system. It's a very well reasoned, very well structured, very complicated with all the generics and stuff, it's an incredibly good, and it's like one of the best generic implementations, that's for sure. Like, there's no doubt about that. If you've used other languages, there's no doubt about it. So it's one of the best, and it's a really good type system. So to use it, use it to your advantage. This is what the same with value objects. Value objects, we was harping on about the same point, right? The whole point of a value object is if you're going to try and express money as a decimal, the problem is anything can be expressed as a decimal, right? It doesn't have to be money. It could be temperature. It could be miles per hour. It could be kilometers per hour. It could be something completely not money. And the really bad thing would be is if you accidentally passed the wrong decimal to the money and you tried to withdraw, £2,000 from your bank, rather than, the temperature outside was 2000 Kelvin or something, I don't know. But, this is the thing, you don't want to get that mixed up. So if you turn that decimal into a value object with using the Vogan library, for example, which is a cracking library, and again, my blog shows you how to use it. He's also got a good README page on how to use it. So they're very simple. It's a one-liner as well, not too much to get started with. And you just say, right, it's now a currency. And a currency has a primitive type, which is decimal, but it's actually a currency object. So now I use that currency object everywhere. And I do this. So I'm not, when I'm talking about this stuff, I'm not coming from a place of like, I've never used eithers and anger. I've never actually created a full-on system. The system I created at Insurex is a beast. It's got about 6 handlers for the API endpoints, and each one of these is either to the end of the world and back, and it's all value object to the end of the world and back. So, I've used it, and I will be bringing out a blog post later to go over sort of the recipes. So that's what we're really missing with this, is the recipe book. It's a very big learning curve, very steep learning curve. But if you had a recipe book that told you how to handle certain cases, it'd be a lot easier. But this is essentially it. And to bring that back, with the value objects, again, it's a compiler thing. The compiler won't let you because the types don't match. And the compiler really likes it when the types marry up. And this is what either gives you. This is what options give you. It's typed. They're type containers. They are types, and therefore they have to marry up and they have to match. I mean, obviously, with most typed systems, you have to give it a bit of a help and a push sometimes, and maybe specify a few types here and there. But in general, you're dealing with types, which means this is why we come full circle with exceptions. You're basically turning your exceptions into sort of like error value objects, as they were. And so, you can store any amount of data you want in them. Each error can be completely different to the next, and you can have any amount of data that you need to make sense of it. And boom, in you go. You put it into your system. You've got a chain of eithers. You've got your business logic in there. You're using value objects. It's all working. And you make a change, and suddenly the type system, the compiler, will pick it up first. The compiler will tell you haven't done this, or you haven't handled this, or you've not finished this bit first. Then after that, then you'll go back to the normal coding things of, crap, I've put the business logic in the wrong place. That shouldn't have been there. I've completely messed up the behavior here. It's doing what I intended, but that's what my fingers wrote and not what I actually intended it to be. So you still have to handle that there. But yeah, so that's basically concludes the part of, error handling and getting to these error handling. And this is why we want to use it. I mean, it does have some problems with it, right? There's 2 parts to the problems. One, it is verbose. There's no way of getting around it. It's verbose, right? I don't know. There's no real ways to, and you need these recipes as well to get it to, to understand it. There's some nuances which you need to know. But essentially what it makes for is a really nice system to use, because when you push something in there and you do something wrong, you get the right errors about all the time. You can see the flow of the logic, and in fact, one of the interesting things is going back to the point about being able to chain these together, which is the beauty of it. It works exactly like LINQ, right? Just imagine all your code looks like LINQ, but it's maps and binds instead. And aggregates, there's a lot of aggregation, a lot of reducers, because they really help. But there was, I cannot remember, and I cannot find it, and I'm going to say it, and we won't be able to link it in the show notes because I just have not been able to find it. And I can't remember whether it is Mark Seaman or Ploe. Is it Ploe, Ploeh? Whoever his handle is, Mark someone. Their teaching scenario is the table reservation system. And he talked about, I think one of the worst things that .NET ever did was say tasks all the way down, turtles all the way down. I think that's one of the worst things, because conceptually that's true, but when you write code, that shouldn't be the case. Or at least I don't think that should be the case. tasks should be left at the boundary of your application, the infrastructure side, the boundary. So whether when you're making calls out to the IO, that should all be tasks, right? And if you look at the hexagonal architecture or onion architecture or whatever you want it to be, tasks should only live at a bound. And people don't like tasks as a function coloring, because essentially this idea that tasks go all the way down, like tasks all the way down, and people fall foul of that because they have the task on the outer edge and then they want to do something else, and they might hit, as their methods cool down through their methods, at some point they might go to the point where they need to hit the repository, and so that needs to be a task. Well, you can't do async inside of sync, so then you have to function color and make everything outside of it as you're going up the call stack to be task of, so that you can get tasks all the way down. But that's not really the right idea, not the right way of thinking about it. And one of the nicest things that I found in using the either library, in using the eithers, is that it's much easier to leave your tasks at the boundary, and much easier to leave tasks at the boundary. The only downside is because you're using either, you don't get either coloring all the way down through your code, but it's synchronous, so there's less things to worry about, apart from the awfully long signatures of your methods. But blame C# for that.
So we've actually spoken quite a bit about, well, a lot about C# and how its exceptions aren't perfect in C# aren't ideal. And I know you mentioned at the very start that you've worked in other languages as well. What do other languages do which maybe C# can borrow from?
Yeah, well, it's interesting. It's an interesting point, and a lot of other languages do it very differently. And in fact, like, you know, so some of the old languages do, you know, like the C++ of the world and the Javas of the world, you know, still throw try-catch exceptions and stuff like that. F# turns try-catch, because it still uses the .NET framework underneath, you still have to handle it, but it turns that into an expression. I think if C# went in that direction, that'd be much better. Go does an interesting thing where you can make a method return a tuple, essentially. It's either an error, which is the first case, and then the result, is it that? I think it's that way around, or is it the other way around? I can't remember. One of the way around. But it's a tuple. Tuples are interesting because with the either monad or the either object, it's a short circuit. So as soon as you get an error, it fails all the way up the stack. Whereas with tuples, you end up more in this world of, if it's not an error, carry on. If it is an error, then either return an error or panic or do something else, you know, or you then make more, it's making the error chain more obvious. And I think that's a problem.
So you've got to explicitly handle almost an if statement almost. Everywhere.
That's the nice thing about either, is the whole point of it, the same as list, is it handles the internals of how to, well, for a list, iterate, for a task to do this thing asynchronously, and for an either to pick the right branch and go down the right route, you know, and it hides all that error code behind this type. And that's my problem with Go's implementation, is that it's very much still in your face. You still have to pick which way you go. You got an error, do something with it still. You still got to do something with it. And again, I think some people also commented that even with that, it's like some things, the documentation still lacks. And I think there's still compiler issues. You know, you're never going to really know what that error is. It's just, is it an error? What can you do with it? It's still a bit lacking in that sense, I think. But then Go is supposed to be a super simple language, right? Very quick to get going, very quick to decide. Rust mentioned, it's a new language, and it took a lot of the functional concepts, and it took this result type, or this what is an either essentially is a result type, and Rust calls it result, and that's what Rust used. Rust used a result type. Again, it's an opt-in or opt-out. You can use it or you don't have to use it, but it is a part of the core language. And the good thing about it, which is what obviously C# is lacking, is it actually deals. You can actually deal with it with the language implementation. So with Rust, you can actually match on it and then go in either direction. With C#, when you're using the either, you're not using the language features. You're having to give it delegates to do the match, and you know you can't use a switch case because again, the switch expression in C# is not foolproof. There's always a default case, which is painful, which introduces awkward states that never exist. That's when you throw an exception going, because we should never have got there, because you can only go left or right. So we've gone further left or further right. I don't know how we've done that. I have no idea. So Rust actually does it quite an interesting way. And that's quite cool. But those are the only two languages I think, obviously there's some Zig and that, which might have different ways of doing it. I haven't looked too deeply into those, but these are other languages that are relatively new compared to C#, which are doing things slightly differently, yielding different results. This is what I think is a problem with C#, ultimately.
Because it's newer, it's easier for them to just almost start from scratch almost, where C# has, you've got the whole backwards compatibility. I think that years ago I wrote a blog post about writing succinct C#, just using some of the syntax we've been talking about. And even for that one, where I wasn't talking about options or maybes or anything like this, it was just normal C# modern syntax, like expression body methods and that kind of thing. Even that one, the replies and the comments were very divided. Some people were saying, really old, .NET framework, like very, very old style that haven't used the modern syntaxes, were very, no, I can't understand this. It's just not readable. And sometimes those were just literally talking about link statements. And so I think the problem that Microsoft have with moving on C# is that it's a balance. That they're trying to make it more functional and do this kind of stuff, but there's a whole load of developers that are struggling with even things like link or some of these new syntax, let alone trying to understand stuff like this. And I bet if you asked a whole range of C# developers what a maybe was or what an either or an option was, I bet only like 1% would have even heard of it. So I think that's the problem they have.
Yeah. And it's a very good point. And my closing thoughts on this is I think Isaac Abraham, I think it was NDC, again we'll link it, he does a talk on F#, well sort of functional, what would functional really mean, something around these bits, but he makes a good point that C# started in 2001, and it started with a set of features, and they never and he expresses this really well, they never like to make breaking changes or anything like that. So essentially they've just piled on and piled on and piled on into C# and carried on piling on. And when you add a new feature, it can't break another feature. And really, like Isaac says, it's creating a really small surface area into which you can add new features and add them effectively. And my final closing thoughts on that, I think C# should have done, the language should have done what .NET Framework did, where .NET Framework went from framework to core, from Net 4.8 to Net 1.0 or DNX, if people remember the DNX days.
I do.
Yeah, just suddenly dotting into something and nothing existing. You're like, why? Oh yeah, we've moved all of these assemblies over here under a different namespace. Oh good, thanks, cool. But yeah, they should have done that. They should have said, right, C# stops at version 10 or whatever it happens to be, and we should now be doing C# next, where again, strip everything out, stop having 50 different ways to create an auto get set property, 50 different ways to create a constructor, having this interfaces with default implementations on, which is just, I don't know, I'm not a huge fan. There's probably good scenarios for it, but take all of these things, and just stop them being where it compiles down into the different levels before it gets compiled to IL, because you're basically lowering each time, right, to get to the underlying. Screw all that. Get rid of all that. Get rid of for loops. Get rid of while loops. Some people are like, what? I'm not listening to this guy anymore. He just says some crazy stuff. But look, honestly, they should have just reduced it back down and then started again with like a C# next or something, or a new language, because this is the thing. As everything is evolving with the horizon, how cloud is evolving and all this kind of stuff, and how other languages are evolving, like Rust and Go and Julia and Mojo and all these other things, Zig and all.
You're just making up words now, aren't you?
Yeah. It sounds like it. Honestly, if I speak programming to anyone else now, they just think I'm just some kind of like loony guy. But yeah, if you look at all those, they're doing some really cool and interesting stuff, and I think C# is going to suddenly, I think it's a cliff edge. C# is like, oh, I'm keeping up, we're bringing some new cool functional stuff, and then it's going to fall off the edge of the cliff as like we can't add these new features in.
I kind of like, going back to what I said before about I think only a tiny percentage of developers actually look at it in the same way as we're talking about, and I just don't think it will, because I think most .NET developers think about it in the way that .NET developers think about it, and they're not looking at the things you're looking at. So I think they're doing really good stuff, and I think each version is getting better and better and more air quotes functional, but they've got to find a balance. And even small changes, because it's a mature language that's been used in lots of different places, even small changes require so much work and thought about, because a language feature that goes in, they can't take out again. Well, if they put it in, they can't take it out.
Yeah.
So it's kind of, they've really got to really think twice before they do anything like that.
Is there ever truly tech debt, or do you just always start again? Because if you just always start again all the time, like these big enterprise companies, they're not going to be churning through their old stuff. At some point, they're going to kill it off, give you 10 million quid and go and start a new project, and you're going to rewrite it all from scratch. So what's the value? What's the value of C# staying? Why not cut it dead? Do a .NET, because these big companies have moved from .NET Framework to .NET Core. They did all that. That's a pretty hefty uplift because they killed it all off. Start again. Give them time. Give them 5 years or whatever. But essentially, does anyone really ever deal with tech debt, or do they just start again?
Oh, I don't know. Using your
food for thought.
I guess using your example of .NET, a lot of the stuff that I ported over, whilst I would do file new projects, new web APIs, so it's like the new structure stuff, I would then take the code, copy it across, and it would still compile. It would just work. And then obviously I'd refactor it to use new language syntaxes. But I would not be starting again, even with that .NET framework to .NET. I can't say Core anymore, but let's say .NET, modern .NET, even that port, it would not be a rewrite. I just think if they did that...
Well, it depends what you're using, right?
Yeah.
If you're using Windows APIs...
Yeah, but...
then it goes, you have to stick to Windows. Like something at some point will break, right? Like so not everything is... There was a reason why there was a cut-off and it was a new thing, right? There's a lot of breaking changes in it. So, I think .NET Framework's really good. I think, it's one of the best frameworks out there because it's heavily productionized, it's heavily performant, there's a lot of people doing a lot of good stuff on it. But, the uptake of C#'s not huge.
No, I think that's what...
And the uptake of .NET's not huge, so how do you stay relevant?
Yeah, that's one problem, isn't it? It's not keeping, where I'm thinking about it in the scope of keeping existing developers, like if they dropped and created something new, that they might lose a lot of people or something. But actually, there's a lot of developers that are just nothing to do with not .NET in the first place. And how do Microsoft actually get those people more interested in .NET?
Yeah. Yeah, because it's a very worthwhile. It's an awesome framework. You can do so many easy things out. Like you can just create an API, have C++, greater performance in JSON serialization than C++. You can have all of that just straight out of the box. Like that's awesome. That's awesome. And a lot of other languages like Go have been trying to do that, and they've got some awesome stuff. So it's like, there's an awesome underlying stuff. It's just I think the language is really creaking at the edges now. Really showing its age, because I think the same thing's happening in the C++ world as well. I think this is one of the major problems in the C++ world is that it's C++ looks crazy now. There's so many different things you can do in so many different ways.
I've not used that in a long time, but that could be a completely other conversation because I'm aware we are running way over time. Just you mentioned about Isaac before. It's probably worth for the listeners that are interested in functional programming. This is way back now, episode 10, we had an episode about functional programming, and that was with Ian Russell, Isaac Abraham, and Scott Vlasham, talking about F#. So that was kind of, and obviously some big names there. So that's kind of definitely worth going back, checking that one.
Yeah, they're god tier. They're god tier guys, and yeah, they're the way they understand and can write F# is awesome. It's just amazing. If you're in F#, they're the pinnacle. That's where you want to hit. They're the peak. Get as good as those guys.
Yeah, definitely. Well, as I say, we are over time. So, with that, first of all, where's the best place for listeners to reach out if they want to,
get on LinkedIn. I'm on X.
No, don't call it X. You're not allowed to call it X on the show. I'll beat that out.
Okay. Well, to be honest, I don't use it that often, but if you want to get in contact there. But yeah, just generally, just hit me up on LinkedIn. And yeah, if you've got any questions, and on my blog post is there in the notes, so you can have a look over some of the more finer details of the implementations. And like I say, I'm going to be putting up a recipes, which I think is going to be a game changing, being able to use this kind of stuff. So yeah, no, thank you very much for having me on. Sorry for talking your ear off.
Oh, that's all right.
It's quite exciting, this stuff. I like talking about this stuff. It's good fun.
I can tell. As I said before, it's kind of like where the listeners can't see your emotion going into some of this, but it's been a very, very fun conversation. Cool. So thanks again for joining us, and a big thank you for everyone for listening. Just a quick reminder that this podcast is sponsored by Everstack, which is my own company providing software development and consultation services. For more information, visit everstack.com. And if you're enjoying the podcast, do help me spread the word on social media. I normally use the hashtag #UnhandledException, and I can be found on Twitter. I won't say X, @Dracan, which is DRACAN, but the best place to get in touch with me is Discord, and Callum's on there as well. So the podcast has its own Discord, and the link is on the website. And we'll include on the website as well, in the show notes, all the stuff we've spoken about today as well. And the website is unhandledexceptionpodcast.com.